Welcome back to our digital electronics series. In today's episode, we're diving into the world of clock generators and timing circuits, often referred to as the heartbeat of digital systems. These components are crucial for synchronizing operations and ensuring everything runs smoothly in digital circuits. Let's explore how they work, their types, and their essential roles in digital electronics. Clock generators provide the timing signals that synchronize the operations of digital circuits. Think of them as the metronome for a digital system, ensuring that all components work in harmony and execute tasks in the correct sequence. A stable clock signal is essential for the proper functioning of sequential circuits, such as flip-flops and registers, as well as for managing timing in microprocessors and memory units. There are several types of clock generators, each with unique characteristics and applications. Crystal oscillators use a quartz crystal to generate a precise and stable clock signal. They are commonly used in computers, communication devices, and other systems requiring high accuracy. RC, resistor capacitor. Oscillators use a combination of resistors and capacitors to generate clock signals. They are less precise than crystal oscillators but are simpler and less expensive. Phase-locked loops, PLLs, are used to generate a stable clock signal by locking onto an input frequency and producing a synchronized output frequency. They are often used in radio communications and frequency synthesis. Timing circuits, such as pulse generators and frequency generators, are essential for creating specific timing sequences and controlling signal timings in digital systems. In pulse generators, it generates precise timing pulses used to trigger other circuits or measure time intervals. They are used in testing, timing, and communication applications. In frequency generators, it creates signals of a specific frequency, which can be used to drive clock signals or modulate other signals. They are important in applications requiring accurate frequency control. Clock generators and timing circuits are integral to numerous applications in digital electronics. In microprocessors, it provides the clock signals that drive the operation of the CPU, ensuring synchronization of internal operations and communication with memory and peripherals. In digital communication systems, it synchronizes data transmission and reception to maintain accurate data exchange and avoid errors. In embedded systems, it controls timing in various embedded applications, from automotive control systems to consumer electronics. When designing with clock generators and timing circuits, it's crucial to consider factors such as clock accuracy, stability, and power consumption. Ensuring proper signal integrity and minimizing jitter are also important for reliable operation. And that wraps up our exploration of clock generators and timing circuits. These components are fundamental to the operation and synchronization of digital systems, ensuring everything works together seamlessly. Thanks for watching. If you found this video useful, be sure to like, share, and subscribe for more insights into digital electronics. See you next time.